Welcome to This Explainer. Today, we're talking about a phenomenal leap in artificial intelligence, stateful AI agents. We all just love the absolute magic of an AI agent that actually remembers a tiny detail you mentioned weeks ago. It's an incredible experience when an agent remembers that you prefer your code examples written in Python over JavaScript, all based on a super quick chat you had maybe 3 weeks prior. But if you're a developer building these stateful systems, there is a hidden villain lurking in your production environment, and it totally threatens to ruin that entire magical experience. It's a nasty little phenomenon called the latency trap. And today, we're going to learn exactly how to beat it using a really powerful technique called session compaction.
Okay, let's dive into this. Have you ever noticed that a brilliant AI agent, one that starts off incredibly snappy and highly responsive, suddenly begins to just crawl as your conversation gets deeper? Well, in theory, modern large language models come equipped with massive context windows. Some of today's models can hold upwards of 1 million tokens. To put that into perspective, that's the equivalent of feeding several full-length novels into the prompt at once. And hey, that sounds absolutely fantastic on paper, but in practice, making a language model reread an entire novel every single time your user simply says hello is mathematically ridiculous. Simply feeding an ever-growing, unbounded conversation history into every single conversational turn, that leads to disastrous performance in the real world.
Leaving your session history unchecked completely destroys the user experience, and honestly, it completely inflates your budgets. There are 4 major penalties when you let your session overgrow. First up, context window limits. Even the biggest models have a hard ceiling, right? You hit it, and your API call just flat out fails. Second, surging API costs. Providers charge by the token, so when you're sending thousands of totally irrelevant historical tokens back and forth on every single turn, you are literally paying the API provider a premium just to process your user saying, give me a second. It's a total waste. Third, crippling latency. More text takes longer to transfer and significantly longer to process, resulting in painfully slow response times. And finally, something called context rot. Think of this like trying to find a needle in a haystack. As you feed the model more and more conversational noise, its ability to actually pay attention to the most critical core instructions completely diminishes, and that often leads straight to hallucinations.
Now, what's really interesting about this slide is the fetch context and prepare context steps that happen right on an application's hot path. You see, a production agent's execution environment is typically stateless. That means the agent essentially wakes up with complete amnesia on every single conversational turn. So to reply, the agent has to fetch the entire session history from a persistent database over a network. This happens right on the blocking hot path, meaning the agent literally cannot proceed to invoke the LLM until this massive payload of text is retrieved, prepared, and injected into the prompt. Transferring 10 megabytes of raw text versus 10 kilobytes of text over a network, that is literally the difference between an instant reply and your user staring at a frustrating spinning loading wheel. Managing a long conversation with an agent is exactly like being a savvy traveler packing a suitcase for a really long trip. The suitcase is your agent's limited context window, and your clothes are the pieces of conversational information. If you just shove every single thing into the suitcase without thinking, it gets way too heavy, it's totally disorganized, and you can never find what you actually need. You might lose your passport under a pile of dirty sweaters. Or, in the agent's case, it might lose the user's core instruction buried under 50 lines of casual small talk. Both the traveler and the AI agent operate under this exact same universal constraint. Success hinges not on how much you can carry, but on carrying only what you absolutely need for the journey ahead. So we have to contrast 2 fundamentally different approaches to handling conversation state. On one side, you've got the raw, immutable log. This is a heavy, completely unedited transcript of every single word ever spoken in the chat. Dragging this raw log into the prompt on every turn is like dragging a massive concrete block behind you. It's heavy and it's agonizingly slow. On the other side, we have a compacted history. This is a refined, highly intelligent distillation of the conversation. Think of this as your sleek, nimble, 4-wheel carry-on bag. It gives the language model exactly what it needs to respond perfectly without all the distracting conversational clutter slowing the whole thing down. And this brings us directly to our solution, packing light through session compaction. Session compaction is the intelligent process of shrinking long conversation histories to preserve vital information while radically, and I mean radically, reducing token counts. This completely solves the latency trap from two distinct angles. First, it shrinks the network payload. Fetching a compacted history from your database is nearly instantaneous. Second, the model's time to first token, the actual compute time required to generate a response, drops drastically because the system simply has far less text to read and process before it can even start thinking.
So the crucial point is knowing exactly how to throw out content without losing that incredibly valuable context. Developers generally have three distinct technical strategies to execute this compaction and keep their agents running lightning fast. Let's open up the developer toolkit and break these three strategies down one by one.
Strategy number one is to simply keep the last n turns. Just think of this as a sliding window over your conversation. The agent only holds on to the most recent conversational exchanges, let's say just the last 10 turns, and it flat out discards everything older. It is the absolute simplest approach to packing the suitcase. It's a really great quick fix to keep payloads small, but honestly, it comes with a major risk. Imagine the user gave a super strict instruction back in turn 1, like, hey, only reply to me in French. And by turn 11, your sliding window just tossed it in the trash. Suddenly, your agent breaks character because it literally forgot the rules. Okay, so strategy number 2 takes things a step further. Token-based truncation. Instead of counting conversational turns, the agent explicitly counts tokens backward from the most recent message. Now, unlike counting messages, which can vary wildly in length, tokens are the actual literal currency of language models. By counting backward to exactly, say, 4,000 tokens, you guarantee your API budget is completely protected. The agent includes as much context as it possibly can until it hits that Strix limit, even if it means awkwardly chopping a long older paragraph completely in half, just to stay perfectly under budget and maintain a consistent latency. And this brilliantly illustrates the absolute gold standard of context management: recursive summarization. Instead of just coldly deleting older messages, the older parts of the conversation are completely replaced by a dense AI-generated summary. As the conversation grows, the agent periodically uses a secondary LLM call, or a plugin, to extract the core facts, things like the user's name, their ultimate goal, their preferences, and it discards all the conversational pleasantries. This highly condensed summary is then used as a substitute for the history, often prefixed right onto the most recent verbatim messages. So you preserve the overall narrative and key instructions, but you shed absolutely all of the heavy conversational filler. It's a real game changer.
Now, if you're a developer looking at recursive summarization, you should immediately spot a potential issue here. Because think about it. If you make your user wait while your agent makes a second API call just to summarize its own thoughts, well, you've just recreated the exact latency trap we're trying to escape. And that is exactly why you must keep the heavy lifting in the background. Expensive operations like running memory managers and generating those recursive summaries must be executed asynchronously. You run this job on a background worker, and you persist the cleanly compacted results straight to your database. That way, the client on the other end is never kept waiting, and the agent stays lightning fast on the hot path.
So we know how to intelligently pack the suitcase, and we know we need to pack it in the background to avoid stalling the user. But that leaves one final architectural challenge. When exactly should your agent trigger this compaction process without interrupting the actual flow of the conversation? Timing these background operations is absolutely crucial. Let's move to and see how this builds a resilient system architecture. Developers typically rely on 3 types of triggers here. First, count-based triggers. This is a simple threshold limit. It executes a compaction job the second your token size or turn count hits a predefined maximum. Next up, time-based triggers. This is entirely driven by inactivity. If the user hasn't sent a message in, say, 15 minutes, a background worker uses that downtime to quietly clean up the session. Finally, event-based triggers, which are based on semantic completion. Imagine your agent just finished helping a user successfully book a flight. That is a completely natural semantic break in the conversation. The agent can use that natural lull to summarize all the booking details in the background before the user starts asking for hotel recommendations. I really want to leave you with this final provocative thought as we wrap up this explainer. Is your agent carrying too much baggage? I highly encourage you to look closely at your own production code. If you are blindly passing massive raw conversation logs back to your models on every single turn, you are bleeding money on tokens. You are totally clogging up your network with massive data payloads. And worse, you are trapping your users in the latency trap. So pack light, implement session compaction, drop that latency, lower your costs, and build the lightning-fast experiences that your users actually deserve. Thanks for joining me for this explainer, and hey, happy building!